Hi, this is Gene Blanchard, and this is Batteries for Bent Brains. We're going to talk about batteries, the different types, the voltages, the amp hours, a little bit how they work, and give you an idea of how to use batteries. The very first thing we're going to look at is a battery. We've got a AAA battery here, it's a small battery. If we measured across the terminals here from our positive terminal to our negative, we'd find it's 1.5 volts. We can symbolize it by saying that we have a tank. And in the tank here, it's a little container, storage container. It's filled with negative electrons, right? All electrons are negative. So we filled it up, and it's this high. From this height down to here, we have a pressure, and that pressure is called voltage, and we have a pressure of 1.5 volts. And what we'll find out is the capacity is how wide this tank is. So we're going to drain this tank of electrons out here. This is our electrical current coming out here, our electrons. And what we're going to do is slowly drain it, and the wider the tank is, the longer it's going to take to drain. And as it drains, the battery voltage is going to drop down. Now on a 1.5 volts AAA battery, it's not really 1.5. When it's fully charged, it's about 1.685. They say it's about 1.5 volts. And as you drain the battery, we know it gets weaker and weaker, and when it's weaker, the battery voltage is dropping down. Let's compare it to a AA battery. So here's a AA battery, a little bit larger, but if we measured from the positive to the negative terminal here, we'd find it's still 1.5 volts. But what happens is it's got a bigger capacity. So what happens is that it'll take longer to drain because it's got more electrons in here. Right? Let's take a look at a 9 volt. A 9 volt battery, what we find if we're doing a symbolic storage container here, the container is going to be quite tall, and it's going to have a pressure of 9 volts. We have all these electrons in here, 9 volts, and it's going to drain out this terminal here. So what we'll find is that as it drains out, it'll be as it gets rid of the first layer here, it'll drop down to 8.75 and 8.6 and then 8, and slowly drain out like this. So we have this container full of electrons, and we have a capacity across here. We have two terminals on a 9 volt battery. We have the negative and positive. Right here we're only showing the negative terminal. Negative terminal is because we have some sort of molecules and atoms that have a surplus of electrons, negative electrons. If we separate it, now we set our negative terminal, we've got 9 volts across here, and it's full of electrons. On the positive terminal, what we have is our symbolic storage container that has atoms or molecules in here that are missing electrons. So in chemistry, they say they're missing electrons and they're ready to accept it. We call that a positive charge. So negative charge, we've got an excess of electrons. These guys are got electrons in their outer shell and they want to get rid of them if we want to get into atomic structure. And over on the other side, on the positive terminal, what we have is electrons or atoms that are missing electrons and they want electrons. So we'll get electron flow that goes from the negative terminal to the positive terminal. If we rearrange this, what we'll find is that we have half our battery here, and we have a terminal that's down in here that has a negative charge on it, and we have a terminal on this side that has a positive charge, and we want electron flow to flow from our negative to the positive. We have an internal electrolyte, and the internal electrolyte is going to make sure that the negative electrons go to the negative terminal, and the positive terminal lacks electrons. How did they do that? Well, it's black magic. It's chemistry. There's lots of ways of doing that. And what we'll find out is that there's lots of technologies. We'll look at some of the technologies a little bit later. So let's take a look at a Carb battery. This is a 12 volt car battery. Inside a 12 volt car battery, it's made up of 6 2-volt cells. So here's a 2-volt cell here, and then there's another one, and there'll be 3 more behind here. It's called lead acid because the terminals are actually made out of lead, and the acid is sulfuric acid. Now, one of the things, this is relatively the size difference. We have our little 9 volt battery, and then we have our big 12 volt. We can see the terminals are super big on a 12 volt battery. Right? So a car battery's got big terminals because what you want to do is you want to be able to handle lots of current to start the motor. Right? More electrons can flow. When we look at a 9 volt battery, the terminals are small. They can't handle as much current. Right? The battery doesn't have capacity to do that. If we look at different types, there's two main different types of batteries. There are rechargeable batteries over here, and there's non-rechargeable. Non-rechargeable are like our 9-volt battery here, or AA battery here, and typically made, they call them alkaline because part of the chemistry is alkaline in there. And what we'll find is that once we use these up, we throw them away. We can't recharge them. They're not good for anything. We have rechargeable batteries. Very common one is lithium ion. That's the popular one right now. They're more expensive. They have a bigger capacity, and you can recharge them. NiCads, older technology. They don't have as much energy per weight as a lithium. And we have our lead acid. And they all have different purposes. Like lead acid, you want to start a car up and you want to move stuff. You can use lead acid. They're also inexpensive to use. Lithium, we start using rare earth metals and it's more expensive to make, and they're smaller, and that we're seeing they're becoming much more popular. And NiCads are the older ones, and you also have things like how many times can you recharge it. Interesting with lead acid is that what you can do is you can keep adding water to it and keep the acid level up, and you can rejuvenate them. These ones, once they're over, they're gone, right? Lithium ion. We have something called batteries have an amp hour rating, right? So if we look at here, here's a lead acid battery. It's got 650 amp hours. It's used for starter motors, electric forklifts, and golf carts. And then we have on the opposite end of the spectrum, we have button cells. You know, these little tiny button cells. They're used for hearing aids and car remotes, and they might have only 100 milliamp hours, right? So we find out there's a big difference, and what their purpose is too. So the amp hour ratings, how many amps of current can the battery supply over 1 hour? That's what the amp hour rating is. And it's a guideline, and it depends on what the use of the battery is for. So for example, a 650 amp hour battery may supply 650 amps for 1 hour. Highly unlikely. That is a lot of current, right? Or it may supply 325 amps for 2 hours. Or maybe it can supply 65 amps for 10 hours, right? So that amp hour rating is sort of a capacity, and then you have to determine how you're going to use it and what you're going to use it for. It could be used a deep cycle battery, like for electric forklift. It might have to run 50 amps or 65 amps for one shift, which is 8 hours before it gets a charge, right? Or it might be rated for a car starter, and they call that CCA stands for cold cranking amps. So it's how much current can that battery put out when it's cold out. So they call it cold cranking amps. So button cells, all different sizes of button cells. This is just a few of them. Most common is CR2032. You use them in hearing aids. So you use the smallest one in a hearing aid. It has to take hardly any current for a long time. Tamagotchi was very popular in the 90s as a game. They used the CR2032 on it. And example, 100 milliamp hour. A milliamp is 1/1000th of an amp, right? So for very low currents, we'll talk about milliamps, right? And maybe the battery can do 10 milliamps for 10 hours, right? So 10 milliamps times 10 gives you 100 milliamp hours. It might be able to do 1 milliamp for 100 hours. 1 times 100 gives you, right? But it can't do 100 milliamps for 1 hour, right? They're not manufactured that. The chemical process that's creating the voltage and the current cannot handle something like that. You can put batteries in series. So here's an example of we got a AAA battery, 2 of them here. And what I have is a positive here and the negative. Then I connect the negative here to the positive of the next battery. And what it does is it forms a bigger battery. So if I measure from the negative of this terminal to the top of the positive, I get my 1.5 volts from this battery. I get my 1.5 volts from that. They add together. I get 3 volts. So it's like I made a 3-volt battery by putting them in series. Over on this side, I've got a battery, positive here, negative, and then I flip this one upside down, negative and positive. If I measured this with a voltmeter, this would be 1.5 volts. This one, because I flipped it upside down, would be minus 1.5 volts. If I added them together, 1.5 plus minus 1.5, I get 0 volts. They cancel. So this serves no purpose. It just gives you an idea that the batteries have to be in the same polarity orientation to work. Otherwise, they won't. You might have done this accidentally if you put batteries in a flashlight and you flipped one over or something like that. If you put batteries in parallel, so what I've done is I've taken the positive of each one of these batteries and connected it with a red wire. I took the negative of each of these batteries and connected them with a black wire. And what we'll find is that each battery is 1.5 volts. And what we'll find out is that the potential difference hasn't changed. It's still 1.5 volts. But the amp hours has. So I've increased the capacity. Right? So this battery has 500 milliamp hours, this one has 500 milliamp hours, this one has 500 milliamp hours. When we add them all together, it's like we made a 1.5 volts with a greater capacity of 1,500 milliamp hours. So we can put batteries in parallel, and then we can create more storage space. So if we needed it to run longer, we could put 3 batteries in parallel. What we'll see is there's lots of different battery packs, combinations. You've probably seen something like this, and they're all they can be in series, parallel combinations to give you the exact battery characteristics that you like. We'll see some like this where they'll package them up in shrink wrap and then sell them, and that some of them are used for the old cordless handsets, landline phones, and some are used in cell phones and all sorts of different things like that. So that gives you a very quick rundown on batteries, and thanks very much for watching. I hope this has helped you. Bye.